Sir, please unmute. Dr. Chakraborty,
Okay.
sir, please unmute.
Okay. Am I audible now?
Yes, yes.
Okay. And now actually this is basic packages you need to import for this session. Import matplot library uh, dot pyplot as plt. Okay, then I know. I think you have already done matplot library also. And now actually we need to import optimizations. Actually, you know this numpy. There is another package scientific Python, that is basically scipy. You can import scipy, and you can also optimize some packages there, sub package import optimize. So these packages you can run from here also. Do you use Google Colab, or this is for first time? This can be little bit slow because this is actually running under the internet, so there can be some problem.
Basically, all are from mathematical background, mathematics teacher or a scholar or like that. So most probably they have not used this. So kindly cooperate of it. Okay, sir.
Okay. Also, there are two other different sub packages for under optimize function. Actually, this is the main package SciencePy, and this is a sub package optimize. Under optimize, also there are some packages for linear programming or some finding root. Okay, so there are or minimizing some function. So these packages also I will actually import from scipy dot optimize.
But sir, your screen is not shared. Sir.
Is this now share?
Yes, sir.
Yes, it is visible now.
Visible but running.
Okay, then audio is okay. Audio is okay.
Audible, but
Am I
screen is
audible?
not clear now. Screen is not clear.
Okay, now is this clear?
No, sir.
Not clear.
Okay, so now go to your PPT.
Is this visible? My Windows is visible.
Yes, yes.
From SCI dot optim. There is basically SCI PY, basically scientific Python, and that is similar to another package NumPy. Uh, but this is actually used for the several uh, works, including optimization also. From sci dot optimize, we can also import root. Okay, that's all. We will import another packages later on. And now I can easily import, and then you know that this is for the code and this is for the text. Okay, whenever you write anything under the text, that will not be compiled, that will be treated as text. Okay. Now suppose I will start from the very basic thing that I want to optimize. Basically, I want to find the root. Very simple function, x square minus 4x plus 4. You know the answer. So for that, basically we can use some function, and that is basically polynomial 1D under the optimize. Okay, I will just write p equal to the polynomial. Okay, define. I will just write p equal to the polynomial. Okay, I will write p equal to
Ajay Babu, please mute it. Ajay Babu, please mute. Okay, sir. Sir, please continue.
okay poly 1D, and then suppose I want to optimize. Basically, I can write here what I want to do. This is a very basic thing. Fx equal x square minus 4x plus 4. You know the answer, but just I will start from this very beginning. Okay, and then how to write this one? I will write the coefficient only 1 comma minus 4, and then the another coefficient is 4 basically. Okay, and this is the polynomial. I can write this is under the numpy package np. This should be given as a array, and I can find the value. Suppose p of minus 1 or p of 0, you can find, and this is basically p of 0, or I can write print also. You know that I must write print, otherwise if I have multiple things to print, then it will actually print the only last one. Okay, so this is the value of the polynomial. If I put x equal to 0, then I get basically this one. Now the next thing is how to find the root. So for that I will just write p dot roots. Okay, so basically there are two roots, and every roots are basically whenever it is repeated also it is basically shown here. Okay, so can do you run this code? Is this accessible, or you can type also? That's no problem. This is very basic thing. So before that, basically only what package you need to use. Basically I have used numpy. Np is used here, and the rest of the things is not used here, but it will be used later on. Okay, can you find this now?
Yes, sir. It is visible.
Okay, so I will give you another exercise. Just you find the answer. Suppose I give you to find the root. Suppose x square minus 1. Find the root of x square minus 1. Then how should you write? Uh, so it should be treated at x square plus say, 0 into x then minus 1. Okay. And then you need to write here, you just need to modify this thing. You can just copy this one and then modify this as, I can treat this one as code only. Okay, so what I should modify here, x square, coefficient of x square is 1, then coefficient of x is 0, and then coefficient of, then the constant is basically minus 1, 1, 0 and minus 1. And I do not need to print the value of the polynomial, I will just write uh, p dot, p is the polynomial and then roots. Okay. Everyone is comfortable till now? And can you
Could you
access the,
minimize, could you minimize the Google Meet page? We do not see the full page of your um, uh, programming.
okay. One thing you can do, basically you can just copy this code I have already shared and you can access that everyone, and that does not depend on the whatever I am writing. Okay, you can also access the previous codes. Okay. Just I want to confirm, is this can you access this one or not? Is this shared properly? You just click on this and you will get the codes. Everyone please access the code. Just click on this, whatever I have shared in the message.
Yes, sir. Clicked on it, sir.
Yes, sir, I access this.
Everyone please access this one. Uh, so that every time you can access the code. If you even lost, you can just copy and paste. Okay. Every time you may not wait. In that case, you need to just copy and paste and you can go forward. Okay. Now I will give you another exercise. So suppose there are another exercise I can consider. I need to minimize this. Okay. And then also I can use another function. There is another function I to solve this. I will explain with you. Np dot polynomial and then polynomial of whatever I can write here, np dot polynomial and dot polynomial, and remember that that should be the coefficient should be entered as a uh, array, as an array we need to write here, and this is basically you can write 1 and then 0. That 0, if the coefficient is 0 you need to specify, otherwise it will actually consider the lower dimensional polynomial. Suppose you write 1 and then minus 1, then it will consider x minus 1 equal to 0. Okay, just I can show you also. If I write 1 and minus 1, then you just show the answer. There is only one row. Okay, so you need to put 0. And suppose I write again another 0, then this will be treated as xq minus 1, and you can show the answer. Okay. And this is actually another function. You can basically execute this thing in p dot polynomial. There is a spelling mistake. But there might be some problem. I just ignored this thing. Actually, you can use the np dot polynomial only. That's all also okay. But the next question is basically I will show how you can plot the or visualize the root also. Suppose this is basically x square minus 1. So how to plot this thing x square minus 1? I think you know that how to plot. Okay. And for that basically we need to generate some values of x, and then we calculate the value of y, and then we can just plot. Okay, that is the very basic thing. And for that basically I write x equal to something, say np dot a range. A range actually that is used to some for loop we can use already. And another thing is basically that can be considered as array also. And suppose I basically plot this function from say minus 5 to plus 5, then minus 5, then plus 5, and basically I take this as 0.01, and I can show you x. Just I need to write x. Okay, this is the value of the x, and how to plot. And basically for that, before that, you need to calculate the y values also. For y value also can be calculated as y equal to x to the power y is basically x square minus 1 or x square minus 1. So I can write x square minus 1. Is this okay? Anyone? Can I write this one x square minus 1 in this? Anyone? I cannot do here. In Python, you need to the exponential is basically double star. Okay? So, and if I write x and then y, and then basically you will get the output of y, not x. Okay, only one output is basically y is shown here, not the x. For that you need to print x and print y. Forget about that. But how to plot? Then plt. So can you remember yesterday's class plt dot plot, and that was basically for data visualization. And then I can write here x and then y. Okay. So this is basically the simple plot. And one thing you need to write here plt dot plot dot show. That does not get much difference. Basically this the whatever text is here, that will not be there. Okay, plt dot show is actually mandatory command, every time we can use. And so this is how x square minus 1 I can plot. But how to basically visualize the roots? So for that basically I need to plot x y equal to 0. So how to plot that on this line? Again plt dot plot, and then I will write so this is x coordinate is fixed, and I need to change the y coordinate. Y equal to 0. So how to write y equal to 0? This is not just a scalar. Okay, for every point of x you need to show the value of y is 0. So I can just write same dimensional vector, or I need to write so x star 0 is fine. Is this clear? X star 0 is basically the vector of the same dimension of s, but every value is basically 0. Every element is multiplied by 0. So I can plot this thing. Okay, there is a one problem. Can anyone tell me what is the error?
Capital X.
Yeah, sorry.
Capital X.
Yeah, yeah,
You
that's
write
correct.
it.
Yeah, that is capital X. So Python is basically case sensitive. Okay, so that is the error. Yeah. So these there are basically two routes you can visualize here. Okay. Everyone, please run this code. So from here, basically you can plot anything basically using this code. You can plot several codes, several function curves using this. So first of all, you need to generate the x values and then y values according to x, and then just you need to just give the x and y coordinates. If you do not give anything, that will be set by default colors or default curve pattern. Okay, that will be taken by default whatever is basically handled by Python. That does not depend on you. Okay, but you can give your choice also. Okay. How much time I have? I think I will not have much time, so I will cover most of the things rapidly. Okay. I will give you something here. So yeah, some of the things whatever I have discussed till now. There is another function I will not discuss. This is similar code to find the uh, uh, roots actually. Okay, and the next question is basically I have already discussed. You can find the complex root also. So just here note this answer: 2 plus 0 into j. Can anyone tell me what is the meaning of this one? 2 plus 0 into j, this is for complex, but this is actually not complex, but written in the complex number format. Okay, 2 plus 2 point 2 point something is basically this is for float, and 0 into j, this is basically written in the complex number format, but nothing is basically complex. Imaginary part is 0. No, okay, so that thing we have already learned, and we can also find the root. Basically you need to change the coefficient and you can get the answer. And basically they are note that here 0.3333 and so on. So how to get only say 0.33? You need to round up this thing. Okay, you need to round up the roots. So for that you can use np.round function. This is the polynomial order. P dot order means basically order of the polynomial. You can see this is second degree polynomial. Okay, and to find the value basically p of 0, and to find the root, that is okay. This is actually another function you can try later, that np dot polynomial, and we can get the answer. This is also written in the same format. Basically note that this is the coefficient is basically written in some within third bracket. This is for the array. Okay, array list kind of thing. And I have just plotted here another curve. Suppose I have another function, say x square plus 10 sin x. Then how to write that one? Basically fx, and the return value is, this is actually function. Okay, and you can also plot this thing. I will show you. Just this is the code of the function. And show here. So this is function. Also, whenever you write the function, remember that the indentation must be taken care. Okay, otherwise you will so you will get some error. So, this is, there is no error. If you just change the indentation, you can get error. Just I will show you. There will be error. Okay, so you need to take care of the indentation. better you just use tab instead of space. Now basically I just consider the x values and I can plot the function. The similar thing. I just copy and paste the code here. This is actually to calculate, or you can write y equal to x square plus 10 into np sin x. That is also fine. There's no problem. And just I write this. This is x value. Or np dot arrange already I have discussed. Then plt dot plot x comma y, or I just write here fx. Basically fx is calculated using this function. And then this is another thing, x square plus cos x, 10 cos x, and this is the plot. And you can basically plot this thing and find the root also. Basically locate the root, you can find from the graph. Just you can locate. There are basically two roots. Okay, you can visualize from here. So anyone please just copy and you can run this code. Now the next question is, suppose I want to minimize this function. Okay, and for the to minimize, basically I need to give also some initial choice. So this is the function optimize. Optimize I have already uh, taken. I have already imported optimize function already here. Imports from science 5 import optimize, that you need to have. Otherwise you will not get output and you will see some error. Okay, I will just this thing I can show you. So this is the result. Just you write result. The result is, you can write result or result on. This is not for your understanding. Only the code is this one. Optimize dot minimize. Under the optimize there is a minimize function, and this is the function to which we want to minimize. And this is the x not equal to 0. This is the basically initial case. Okay, if I give this thing, then I will get the answer. Say functional value is here, and what is the answer? The x minus 1.30. Okay, another thing is basically you just done this thing. So for that you need to also run this code also. I will then explain another thing. Just you run this code, copy and paste this thing. Okay, so this is an initial choice, and I can also change the initial choice. Suppose I can write instead of x not equal to 0, I can write x not equal to say 10. That is also fine. Basically in this case global minimum value is shown here. Okay, this is actually the minimum corresponding to the minus 1.3. Okay, and the value is basically value of the function is minus 7.945. You can also give the method by default. There are three methods are basically set by default, depending on whether constant is given or bound is given. and that is taken care by Python. If you have any specific method, then you need to specify here. Otherwise, you need to basically you can skip this thing also. Just you can give the function and then initial choice. Okay. These are the basically method you can specify here, and there are three by default method. This one when for no bound and no constant, and this is with bound but not constant, and when you have for constant and without bound, so you can actually use sequential list square programming. Okay, there are other methods also you can just consider later on. You can check. One thing is basically suppose there is some several problems about the whether you can choose the how to choose the initial choice. So for that basically we need to use uh, this function. Okay, so when you need to take the initial choice, here actually you can get the choice. So optimize the dot basing hopping basically. Okay, so if you use this one, you can get this result. Though in this problem there is no problem about the initial choice, but in some cases you need to find the initial guess using this. You can use that function. Okay. In this case, you have do not have any problem. Uh, so for this one also you can find the root. There is no problem. You can just write the function and you can use the seven. This is already done. So another thing is that, so this is how illustrated using the, I just plot this function and then the root is basically shown here. The similar type of code you need to use. This is the x values and this is the functional value. X plus np cos x. Np is basically numpy, nothing else. Np dot cos x, basically cos function is considered under the numpy. Otherwise basically you find the cos for univariate value, that is no problem, but for the vector or the list or something array you need to use np dot cos. Okay. I have just located this point where when 0 point is actually that's all, nothing else. And the answer also you can show here. And another thing actually I can show you. Suppose I want to, there are basically two variables x0 and x1, and there are two equations also. So for that to optimize you need to use this code. Basically first I have written the uh, functions actually. X0 minus x0 is basically you can consider x, and x1 is basically 1. So that thing I have written here first. Then another thing I have written. Okay, and next thing actually I have given here the differentials, and it will basically return f and df, and using that basically I have found the code. Okay, I just show you the code. Okay, so this is for the functions, and there are basically two equations you can write here, and the derivative of that, and we need to give the function to whatever is basically written here, and this is the initial choice, and Jacobian equal to 2, method equal to Lagrange multiplier. Okay, ln. That is the solution. SOL basically this is the name. You can write anything, and sol dot x you need to find for x values. Okay, answer the x values basically will be given here. So can you Do you run this code? Okay, I can just show you.
Sure.
Okay, just tell me. Okay. Is there any questions? Okay, then I can just continue. Uh, Actually, in the next session, in the next couple of minutes, we will actually basically spend on linear, how to solve basically linear programming problem, and this is very basic thing, how to find the roots. Okay, and another thing actually we will cover here, how to find the um, solve the linear programming problem. Okay, uh, till now is it okay? Then actually we will go to the next topic actually. Okay, so we will start from the very basic equation. Only the this is the objective function, and there is only one constant: x plus 2y less than equal to 10, and x greater than equal to 0, and y greater than equal to 0. So first of all, actually I will plot this. Okay, so for that one, so you need to consider the x values. So a range of the x values I will take, and then y value I have already calculated here. I will just show the two things here. Only this thing I will explain this. So this is the x value. Already you know that how to calculate. This is actually linear space also okay. We can already written there np dot arrange, that is also okay. And from 0 to 12, and there are basically 400 values, and then y is calculated here, and I just plot this thing, just only this straight line I have plotted here. Okay, this is just the straight line. Then how to plot the actually inequality? This is the equality, this is for equality. Now what, how to plot the inequality? So for that one, actually we need to plt dot fill between, plt dot plot for the straight line or curve, and plt dot fill between. Okay, and then xy is basically given, and where x should be greater than 0, otherwise, and y also greater than 0, otherwise negative values will be taken. This will be the half spaces. Okay, and color is basically given, otherwise color will be taken care of by python. And this is the label feasible region, I just show you. So this is basically the equation, x plus this equation, actually whatever written equation is here, x plus 2y less than equal to 10. Okay, and another thing actually I will show you, this is the axis also I can plot. Okay, so there are basically three extreme points you can see here. And so can anyone tell me what will be the answer in this case? Anyone? This is basically to optimize 5x plus 4y. Okay, anyone? What will be the answer?
From the participants, what is the answer of this problem? Have you solved it? Sir asking you. Hello,
Sir, I have,
participants.
sir, I have a doubt.
Okay. Okay.
Yeah.
Sir, in the code, what does that alpha is equal to 0.5 mean, sir, in the code?
You can just change and I can explain that.
Sir, in that PLT dot fill between section, alpha equals to 0.5, sir. Sir, what does that
Okay,
mean?
no problem. Okay, I just change it. This is the darkness. Okay,
Okay, sir. Okay, sir.
this is
Thank you,
more
sir.
dark. Any questions? Okay, and then I just want to know the answer. What will be the answer? of this? Okay, so how to solve this thing? Anyone? Have you already learned linear programming or not? I think you have also learned this thing in higher secondary. Okay,
Maximum z equal to 50.
sorry.
Answer is 50. Maximum value
Okay.
uh,
So the,
using Rajasthan.
you can find the extreme point also, and you can calculate the values, and you can just compare that. That is also okay. But suppose I will visualize this thing graphically, then what I should do? Okay, that thing I will do. So you can expect any values of the objective function. I will just plot that thing. Okay, for that one actually I can consider say 20. Can this be, this can may or may not be in the feasible region, but I just plot this thing. That's all. And after that I will modify. There is no problem. And this is the one line, so you cannot compare. I will give you another thing. Say this is not 20. I can just, if I increase the value instead of 20, I can just consider this one. And as 30 or 40, or I can decrease also this, but this is the maximization problem, so my target is to increase. Okay, say I can write here, this is not the 30, I write here 30, and then I need to modify here. This is how this is written. Can anyone tell me how this is 30 minus 5x by 4? This is basically objective function equal to 30, and then you solve for y. That's all. Okay, and I can change the color so that this is say red. So in this direction, if you move, you will get maximize the objective function again and again. Okay, but till when? I can show right here say instead of 30, say I can write here 60. So this is outside the feasible region. This is the feasible region, you can see here. So this is how also 60 cannot be the value of the objective function. So I can write here 40 or 50 also. I can just check this thing. So 40 is also not okay. So I can just suppose write 50. Forget about this thing. This actually the label will be. I am not modified this thing. So you just visualize this thing that this 50 can be the answer. Okay, and this is basically the corner point. Okay, so you need to move this line, and this is the corner point, and this will be the maximum value. Okay, is this clear?
Good luck. The calculator you use method
Hello,
in here.
I
Hello,
didn't. Hello.
hello. We use Gaussian method. Then I calculate the value. Maximum z equal to 50.
Sorry,
But
madam.
here,
I did not get your point. Sorry.
okay.
Uh, Madam, please tell me. Is there any doubt or anything wrong? Okay.
Any queries from the audience? Any? Otherwise, sir will continue. Okay, sir. Please continue.
Okay. And just I show you the full code and you can run that thing. So I have already discussed. This is basically a couple of lines are there. That's all. And I can show you here. Okay. So you can observe here. This is the actually the actual solution. And in this direction, if you move, then the value of the objective function is increasing. But after certain point, you will after some certain point, basically certain movement, you will basically leave the feasible region. So you need to keep in the feasible region also. So that's why this is actually the solution. Okay. Now, so you can just copy and paste this line. I have already explained these lines, of course. X limit, y limit, actually you can modify. That this is from minus 0.5 to 12. Basically, I consider 0, 0, 0. So in the middle, not at the corner. So that's why I have taken minus 0.5 and 12, 10. You can just experiment on this, just changing the value. Okay, if you have any doubt, so the best thing is actually I say you just change this value and see what is happening there. Okay, so do experiment. There is no problem. You may face some problem, you may get some error, but that is also learning. Okay, in coding, if you get error, that is also learning, because when you run in the code in the next time, you will also face the same kind of error, but you run if you know the error, then you can just modify the code. That is the benefit if you get the errors. Okay, so we have only one object. That is very simple problem. But suppose, and also I will explain how to solve this is basically by say any not by graphically method. I want to solve this by say simplex method. Okay, so that can be done. But though this is simple, but let us begin from the simple case. Okay, so for that you need to specify the c equal to the objective function, and this is taken for the remember this thing. This is for the minimization problem. In this case, our problem is basically maximization problem. So I just consider this is the my that's why this is -5 and -4. That's all. Okay, and there is only one constant 10 and 2. Okay, and that is the right hand side, b underscore ub. Basically this is actually commonly used in the coding. Okay, that's why we have also written a underscore ub, and b underscore means aub less than equal to bub. That is one. Suppose if you have some constant greater than equal to, just you convert, less than equal to just multiply by -1. That's all. Okay, and this is the upper bound, basically bound of the x and y, basically 0 to none means infinity. Okay, there is no bound, and 0 there is, this is 0 and none, basically x greater than equal to 0 or y greater than equal to 0, that is written here. And this is the bounds basically consider, and this is the code actually linear programming. Actually for that you need to import linear programming linprog, that thing you need to import. So just import this one. Those who have already imported, just you need to import this line also from sciencefile dot optimize import linear programming. Okay, otherwise you will get error. Okay, so this is the basic thing you need to import. So I just write the what you need to write here. So this is the code. Okay, so you can just copy this thing, and of course you need to run. You just copy and paste there, and you will also again paste the code. Okay, you need to run, not only copy paste is the thing. Okay, you need to run also. So this is the thing. I will also show how to solve this thing by simplex method. So for that I just share the code. Is this okay? So how to write the equations? So this is C for the objective function np dot array basically array. Now array is basically handled under the numpy. Okay, numpy is basically written as np. Okay, so np dot array is basically written here. Everything is written in the form of array, and then bounds are also given here. And this is the simple code to solve. But before that thing, this is actually thing you need to remember. You need to understand actually. Okay, I just copy this thing. Okay. Mm, this is minus 50, and basically we need to change the again objective function. That's it. We have already changed the objective function by minimization from maximization to minimization, and that's all. Okay. And the value is basically 10. This is 1.00 e to the power 01. So this is basically not this is 1, sorry, 10, and this is 0, 0.00, and e to the power exponentiation is also 0, 0. So this 10 comma 0 is the solution. Okay, so this is basically very basic thing. But if you have any constant, then we will see that how to modify that the constant. We will go in the next section. Okay, so everyone get the output. Just run and tell me whether there is any problem or not. Is this okay? Just run and tell me. Okay. Now basically we add an additional constant to this, 3x plus y less than equal to 5. Okay, everything else is remains same. I have just added another constant, 3x plus y less than equal to 50. And so for that basically I just plotted this thing, and you can see the how it looks like. Okay, just I will not plot these things. Just forget about the objective function. I run this. Okay, so this is not the solution. I will not share this thing at this point moment. But you can say that this is basically the feasible region, the intersection of these two constant. Okay, so this is actually there are basically four corner points. And then this 10 comma 0 is not in the feasible region in this case. So your value of the objective function will also change. And so how this basically change, I will explain here. How to find the values. So for that basically I just plot one line of the objective function. Okay. This is the line. So can we basically, you can always observe that it can be either minimized or maximized. This is not the optimal solution, because this is in between. I can also go to this direction or this direction. So minimization or whatever is there, I can go. So now the next thing is I can modify again. So this is 20, 30 and 32 and 40. I have basically 30 written 32. Basically you can see this is actually the actual solution. I run this thing. So you just observe this thing. So this is the beginning, and then I move further 10, then 20. This is 10, this is 20, and this is 30, then this is 32. This is actually the solution. And then if I move further, then I will go outside the feasible region. Okay. So what is the difference here? Only one constant, that's all. This constant actually, nothing else. This is similar to the earlier code, only this constant 15 minus 3x. How 15 minus 3x comes? Y equal to 15 minus 3x. So you need to give x and y. And then, so to give y, you cannot give independently. You need to solve the equation y equal to something. Okay. So I just share this thing. So you will get this outcome. Remember that you need to import the packages. Otherwise, you will get something. Okay. At least one time you need to run the packages. If you restart, then you will need to run the packages. Otherwise, you will face it. Everyone got this or not? Okay. Just tell me in the message how many of you basically done this. Tell me in the message. Done or no? Okay. Anyone else? If you have any problem, just you can tell me and I will see the what is happening there. I think you got the answer. There is nothing error. I think. NumPy dot integer 64-bit. I think there is no error. Do you have any error? Actually, in this line, okay, just I can suggest one thing. Just you copy and paste the code. Maybe something you have not pasted properly. Anyone else? Not working. Okay, then I can actually refresh this thing. I think I do not. So it is now updated. Not now working. Okay. So anyone else done this or not? Okay, just you just copy this thing. Okay, so now the next thing is how to write this thing using solve this thing using simplex method. So actually we have done this thing, but now we have additional constant. How to write that thing? Okay, so what is the only there is only one modification. This is here. This is the equation 3. Not this is the for the constant. 3x plus y, and this is 15. These two are only modification. That's it. Uh, Actually, in this case, minus residual dot function is written. Basically, we have converted the function. That's why this is minus. Okay, because that is maximization problem. But in case of this, by default, this is considered as minimization problem. So you need to just convert the objective function. Okay. Uh, so I can solve the copy this thing and share this thing. Same thing actually. This is done and solved using the simplest method. Only the modification note that this is actually written here. And the 15. 3x plus y less than equal to 15. Objective function is basically same, and the first constant is also same. And bound is also there is no difference. Okay. There is only two variables, x bound, y bound. If there is another variable, then there will be z bound. Okay. Just I run this thing. Okay, so this is the answer. Everyone, please run this. Only note that only one modification here. So can anyone tell me how to, suppose I have another constant x plus y less than equal to 5. What I need to do here? Again I will add another row. Okay, 1 comma 1 and less than equal to say whatever is the value in the right hand side, I should write here. Okay. Another thing, suppose I use some additional variable, say slack variable or circle variable, then in that case also you need to write here 5 minus 5 comma minus 4 then 0 0. Otherwise you will get different value of the objective function. Okay, is this clear? Do you understand or not? That's all. If you do not run, at least you can run. You just, if you understand, then you can run. If you have any doubt, just tell me. There is nothing about the completing the syllabus. Okay. And another thing I will explain here. Is this okay till now? Is this okay or I should wait?
Sir, I have a question. Actually, in you actually shown the linear programming problem in general way. If we get the integer form,
Sorry.
the values of the variables are integer, or any the objective function is nonlinear type, or objective function or constant are also nonlinear type, or
There.
any others. There are so many methods in linear programming
Yes, there.
problems or operation research. Suppose you like a dynamic programming problem. So how can you solve this? Optimization, in optimization methods, there are so many methods.
Yes, yes. For that you need to actually write the function, and you can use different methods. A least square method you can also use. There are several methods are actually written there. So under that you need to do that. Okay. And this is for actually whatever I am discussing here. This is for the linear programming. And for the other cases, you can also solve the least square problem or anything else. You can solve. You can also solve.
Actually, Ajay, your question that is there is a sound problem or communication problem because your
Okay, sir.
questions were not clear to the our speaker. So you can repeat your question, Ajay Babu. Ajay Babu, you can repeat your queries to our speaker. Ajay Babu, please. in first time your sound was not clear. Okay.
Actually, when
Yeah, yeah. I have understand there is a
actually here the
networking problem.
takes any real value,
So not
negative real
clear
values.
now. Till now your sound is not clear. So speaker cannot answer your proper question.
Oh, okay.
Uh, your network is problem. Networking problem is there.
Okay.
Okay, sir. Sir, please
Yes.
continue.
Okay.
Okay, sir.
So next part is basically I will concentrate on. Uh, so this is not the actually some inbuilt method. I will show how to suppose actually in linear programming we also find the basic feasible solution. Okay. So this is basically some kind of solving some linear equation. That's all. So for that basically I have considered here how to solve the find the basic feasible solution and then the optimal solution. So for that actually this is the objective function, that's all, and that is also this is the equation, and this is written in the form of uh, some array. Actually I write here, suppose let us consider actually the equation I have introduced to for write this form in the form of equality. Actually I have introduced two other variables also, okay. So after that basically we get this matrix 1 2 3 1 is already there, then 1 0 and then 0 1. Okay. uh, and the right hand side is basically same. uh, then there are basically four, okay, four variables, and we have actually two equations and two constant. Then how many basic feasible solution we can find here, actually you can calculate, and I have actually calculated that thing using uh, some loop actually I have already considered here. And this is for actually I can be run from say first, second, third, fourth, and basically in Python this index is index start from the zero, and then one, two, three, and so on, and the last value in the range m plus one. M plus one is not considered. M is basically three, so three plus one means four actually. Zero, one, two, three, four. There are four actually variables. Zero, and out of that I just modify the another thing. The first row is only first in the first case. The first row is taken. Then I just first column is taken. Then I can basically second take the second column. That is basically x3 and x4 equal to 0. Okay, there are basically non-basic variable. For that we need to solve. This is actually the solution. How to find the solution? np.linearalgebra.solve. Okay, this is just a inverse b, and we get the basic solution, and the corresponding optimal value also we can calculate. This is done using some loop. Actually there is nothing about the inbuilt code. You can write this thing and you can see here that this is the value. uh, this is the actually x, y, and say there are another value are also there, then 4 or 3. This is actually the answer we have seen, and the other values are there, but note that this is actually minus 15, this is minus 20, this is not uh, this is infeasible, not feasible. Okay, just you see here and you can find the answer. Okay, you can also tell me what it will be the answer. This is maximization problem. There are basically six values, and this is basically 25, but 32 is actually the answer. These two are not feasible solution. Okay, so the same problem can be solved in the different ways. I can also share this thing. Okay, you can run this thing. If you have any doubt just about this code, you can tell me. Here we do not need to write -5 and -4 because this is z equal to something, so I can just write 5. Maximization, forget about the maximization or minimization, and this thing actually not considered. You can just ignore this thing. C is not used. Okay. If you have multiple values, also multiple values and multiple variables more than 2, or then also you can write modify this code. You need to just modify the loop. Okay. If you actually already learn the loop, for loop, then you can understand this thing. Okay. Range m plus 1 means 0 to m, not m plus 1 exactly. Okay, 0, 1, 2, and then less than m. M is basically 3. Or you can write m equal to 4, then here m. That is also fine. That is nice. Okay. And I have considered j greater than I. Why? Otherwise, this will be repeated. Okay. So 1, 1, 1, 2, and then 1, 3, then 2, 1, sorry, 2, 3, and 2, 4, then 3, 4. That is the basic. Okay. In the next thing, I will consider another cases. Actually, in this case, uh, you need suppose the feasible region is not bounded. Okay. So this problem consider when the feasible region is not bounded, then also we will visualize the uh, optimal values whether they are exist or not. Okay. In 2 dimension actually you can have that benefit, but in higher dimension you can 2 or 3 dimension at most you can. Okay, just since there are a couple of minutes, I will just show you how this is working. So there are, this is the feasible region, darkened region, and note that the feasible region is here is not bounded. Okay. In some cases you can have the optimal solution. In some cases you may or may not have the optimal solution. In some cases you can have the unbounded solution. Okay, not in the earlier cases. In this case you can have unbounded solution. Value of the objective function can be unbounded. Okay. So just this actually you just move the in this way. This is the blue line, and then if we increase, then you will get the red line actually the optimal values. Okay, red line basically 1.5 is the answer. Okay, in this case you can have the unique solution. Okay, and unique optimal values, only one solution is there. But if I just change the object, change the constant, sorry, objective function, this is actually the solved by the simplest method in the similar way. Same way actually this is solved. Just I need to modify the, you need to just modify the constant and the objective function. That's all, nothing else. And the I just modify the objective function. Z equal to say x minus 1, maximize z equal to x minus y. Then you can see here another thing, that this is the value of the objective function, but the graphical method actually little bit more clears the picture actually. So you just consider here, note that this is actually this portion is the actually same optimal value, and this is actually 0. 0 is the actually answer, and this area from 0 to this portion, and you have multiple solutions in this case, or alternate solution. In these two corner point joining this, if you join this two corner point, any point between this, that can be your solution. Okay. And another thing is that I will just consider the objective function, modify this one, minus x plus 3y, and then if I run this thing, this you can get the answer exactly one answer in simplest method. But when you visualize this thing, you will get the answer is the optimal value is basically this line, minus x plus 3y equal to 3, yellow line. But there is only one corner point, but in the other case there is no corner point. This is actually the x value cannot move, this coordinate can move increasing. Okay, but you will get the same object value of the objective function. So here feasible region is bounded, but note that you can have finite solution. But now I will just modify the objective function in another way. So you will see here the object value of objective function I have modified on it. And then I can run this thing. So this is for I can change the color also. Okay. So for 5 say blue, and then red, then green, and then say yellow. Okay, there is filling step. BLA. Okay, another spelling step. Okay, so this is actually increasing, and there is nothing bound actually. You can increasing unboundedly, and basically the value of the objective function remains increasing. If you just change the value, you can move further. Okay, in this case, and this is actually there is unbounded solution. Okay, so this is the case, and you can solve this thing, and what you get, you can also check. And note that actually in the same problem, if you just change the objective function, you can have different answers. And in some cases you can have the unique solution, in some cases you can have infinitely many solution or alternate solution. In some cases your objective function can be unbounded also. Okay, and there is another questions or another here x1, you can have the bound on x also, a lower bound as well as the upper bound you can give, and you can basically plot this thing, and this is the case, and you can just solve this thing, or there is no issue. I will not explain this thing. So this is actually how you can solve the two curve, and the point of intersection you can find. Or another thing actually I can explain you, if you have some very basic thing I have already discussed with you. So this is the polynomial, you can visualize. There are 3 points where this y equal to 0, fx equal to 0. Okay, another thing actually curve fitting, and actually sorry.
The remaining time is 2 minutes. Please finish according to this limit
Okay, okay,
because the second session start at 1:30.
okay, okay, thank you.
So,
So just can I just one, so at least just one thing, only 30 minutes. Okay, 30 seconds, sorry. I just show you how you can plot.
oh, okay. Okay, sir. Okay, okay.
Just this is the data. Suppose I want to fit some car on this, I can also do this thing using this, and I can share this code with you also. Then you can see here, this is the data, and you can fit any car, non-linear curve also. This is actually done by non-linear square. Okay, so there is the non-linear square optimization technique is used. Okay, so this is the end of this.
Thank you, sir, for your helpful talk. And now I invite anyone who has a question or would like to say something to Dr. Chakraborty. Then you can ask now. Anyone have any question? Please ask.
Hello. Hello, sir.
Hello.
The objective function is nonlinear type.
Yes, yes.
If the objective function is nonlinear type, is there any changes of this program? Also,
No, in
the
nonlinear,
linear.
nonlinear type also you can solve. Using the this actually optimize function, you can do that. This is another science by scientific Python. Okay, you can do that also. Nonlinear programming or nonlinear optimization also
Saying
can do.
there is in a linear.
And that can be done. Okay, but this is not covered here. Anything
Any
else?
sir, another my query is game problem. Game theory problem can be solved by our this type of programming language that is in by under the Python.
Yes, sir. I think there may be some code, but I have not tried. But we can develop code. That is the good thing. That is the good thing.
Okay.
For example, actually, I have explained the one thing that is basically to how to find the basic feasible solution. This is basically done some using some for loop. That is okay. So it
So,
is
say one is a non-linear programming problem
yes,
using our lingo or another method. But if I use the Python,
yes.
so which one is better to you think that, sir? My query is that.
Actually, sir, I have not explained many things, but I think it can be also used. There are several packages actually. That is the good thing. That if this is not available in this case, only there can be several other packages also we can use.
Okay. So, any more question from the audience? Okay. Okay. So thank you, sir. Thank you for your nice presentation. Not only that, you have discussed too many parts of our programming problem that is in optimization method. Already we have learned in our college level, that is UG level or MSc level, the linear programming problem, basic optimization problems. So you have discussed, and it is very beautiful. I think that it is very interesting to our participants. Thank you again. So
Thank
from the organizer, you have the certificate. Now I
you.
want to hand over the certificate on behalf of the organizing committee through our virtual mode. So please wait. I want to hand over the certificate.
Thank you, sir.
Okay, sir.
Sir, can you share the PPT notes with us?
Yes, yes, I will share. Yes,
Thank you, sir.
So is it visible?
yes, sir.
Yes. Thank you, sir. This is your certificate. Um, you have given your nice full lecture to us. Thank you. Thank you again. A lot of thanks. So this is the time of perfect time of our lunch period. So, dear participants, we shall meet again at 1:30 p.m. For our sixth technical session, and then there is another session, that is the valedictory session. So, all are welcome to that session 6 as well as valedictory session. Now we are ready for virtual lunch time. Okay. Biman.